It is June 1st, and I have a strange goal this month of doing a short video every day. And they're gonna be a little more raw. They're gonna be whatever I happen to be doing or a part of my day. And the goal is for them to be really easy to edit. Maybe there's something in each video you can take from it fabrication-wise, or maybe it's just a silly video. But I'm gonna try something out. I'm taking a little inspiration from my man, Garrett Mitchell, AKA Cletus McFarlane. He's doing the Month of Freedom, or he did for May. And I just wanna see what happens. I wanna see if you guys like it. I wanna see if it inspires me to like create more content, because I've gotten a little stagnant. But anyway, enough talking. Let's get into it. Day one. Okay, so I have a little project here that I wanna knock out that's been sitting on my fab table for a long time. And that is a fire pit that Spike cut the parts out for a long time ago. I have this octagonal base plate, eighth inch steel, cut out on our plasma cutter, of course. And then these two basket pieces. And then over here, I actually have two more pieces here. And these will also get bent. So now that I have the Titan to a point where I know how to use it, I can, if this becomes a product that we want to make faster and more regularly, I can load the program in here. For those that don't know, this is the Titan 25T from Langmuir. It is a CNC press brake. Press brakes bend metal. That's its job. And the CNC part means I can program bends and it can be accurate and repeatable. So let me measure. So the angle I need is 139 degrees. And I could tell you how we got there, but I'm just gonna say that that's what it is. And what I need to know to tell the machine how I want this is how long the bend is. Where's my tape measure?
It could be anywhere. This, you see this one? This is not yours, and it's here. Yours looks like that. It's dirtier, and it could be anywhere. Is that helpful?
You only know where yours is because you don't use it ever. All right, seriously, where is my tape measure? If I had a nickel for every minute I spent in my day looking for my freaking tape measure, I wouldn't have to use a tape measure anymore because I'd have a lot of money. I'm stealing my backup tape measure, and I know I will find my other tape measure in a really stupid, obvious spot. So here's how this is gonna work, if we do it right. This is going to make the base of the fire pit. This is the bottom plate. So this is sort of, these will make sort of the feet. Bottom plate, and this is what will make the actual pit, the bowl, if you will. So I need to bend along this seam. Spike gave me a little cutout right here. So I bend along this seam here. And the same thing here, I need to bend along this seam. So, if I measure this, it's a 9 7/8 bend. 9 7/8. And this one is 3 5/8. 3 5/8. Ow. Ow. I think I just cut my lip real bad on a broken Sharpie top. One video a day thing's off to a great start. All right, so I'm gonna attempt to show you how to do this. So first thing you do is create a bend. And, well, I gotta home the machine first. So we'll start by homing the machine. Moves the rams up. Okay, and now I gotta home the back gauge. Okay. We'll not be using the back gauge for this. So the next thing we do is create a bend. And so what I want to do, I'm going to call this bend OCT fire pit BTM bottom. Okay, and it is the extreme gooseneck die, which is this. There's the part number. Extreme gooseneck die, 85 4-way die with this 7/8 opening, hot rolled steel. My desired bend angle is 139. Okay. And I'm going to prepare for an underbend compensation of 8 degrees. Material thickness should be 0.125. But what I've learned is that it is prudent to actually measure the thickness of your steel. But there's here we go. My calipers. It's slightly under 0.125. I'm going to just say 0.12. 0.12. 120 wall, bend width. So this is where we put in that value. So if this is the bottom, we're going to do 3 5/8. So 3.625 or 3.6. Okay, no back gauge move. And we are going to save this. Now we go new bend move. And we go oct fire pit top. Okay. And then extreme gooseneck, 4-way die with a 7/8 opening, hot rolled steel, bend angle of 139. It's going to be underbent by 8 degrees. Material thickness is 0.120. Bend width is 9 7/8. 9.8. 7, yeah, 9.8 is fine. And we'll save this. So, okay. So now we go over here and we go to new program. We're going to call this oct fire pit. Okay. And then we want to add a bend. We want to add this bottom one. Add. So it's going to go 1, 2, 3, 4, 5, 6. I'm going to add that 6 times. So 1, 2, 3, 4, 5, 6. All right, and then we want to do the top. 1, 2, 3, 4, 5, 6. Okay, so now you can see we are 6 bottom bends, 6 top bends. So we'll hit save. Okay. Program bend mode. All right, so now we do it and we figure out if it works. So the first thing you do is get the die to go down to the bend position. So you do that by, we run the program, we hit yes, and then we hit both of these, and that gets the die down to where there's just enough space in between to slip the metal through. Okay, and it stops. Now I grab this piece. All right, I'm going to line it up my die. Okay, now we double tap the foot pedal. I'm gonna make sure that this is got enough space, it should. Yeah, okay. Down, up, down on the foot pedal, clamps the piece, waits 3 seconds. Okay. I'm a little worried that's too much, but let's check and see. So, turn this on. We have a bend of 138.1. Okay, so what I can do is edit this bend and do, see, cancel this, okay. Edit this bend and do, say it was underbent by 7 degrees. Should remove, wait, no. 138, 139. Yeah, it was underbent by, there we go. So hit save, go back to run. Okay. I should be able to keep going now. So see, it's got all my bends lined up and it's on the second one. Do it right here. And I'm just going to down on the foot pedal. It's clamped, I like that. So here it goes. Okay. That should be 139. Sure enough. Okay. Spike, it's happening. Yeah, I got it dialed up.
Can I borrow the grinder with the steel cup on it?
Mm-hmm. Yeah. Spike set me up for failure. We did the math, I thought, and came up with that bend angle. But then I was on the phone, and now he's gone. He's saying that bend angle was for this piece, not for this piece, because this does not fit now. It's overbent. It doesn't meet up when I put this here. So, this project I've been staring at for months and was excited to get bang on with my CNC press brake has been sabotaged by Spike. Well, I'm gonna move on and see if it applies, see if these come out right. So let's try that. I'm gonna go to my program, pick step number 7, and hit run program. Yes. change the underbend compensation to 7. Save. Run. Step 8. Run program. Yes. Okay. Just kind of eyeballing this. Trying to put it underneath the right spot. Should be good. See, that fits. That fits really well. So yeah, the 139 was for this part, not the other part. But that's pretty cool, man. I can already see how this CNC press brake can be a money maker. So let's run the next 3. Program completed successfully. How did this part do? Very, very cool. Very cool. I like it. So these panels could be anything. Could have designs and stuff cut out on the side. And just a little bit of stretching. Anyway, this is good R&D. I need this seam to be as easy to weld as possible. So what I'm seeing right now is when I make this side touch, this side opens a little too much, and it's almost like the bevel of the base plate is pushing it out a little too far. So my corners are starting to fight each other. You know, from here to here it lines up pretty good, but from here to here it's starting to fight it a little more, and then it's cumulative. The effect is cumulative. By the time you get here, and then by the time you get over here, there's a real big gap. I mean, it's not that bad, but if you kind of stretch it and force it, it gets pretty okay. I think there's something here. Kind of bummed I ruined this piece, but I'll make it Spike's job to fix it. But I like it. I like using this thing. Anyway, that is the end of day 1 of Month of Fabrication. Thanks for watching. See you tomorrow.